Okay, estimating the arc length of a curve is something that we need to fix that up. First of all, if we do have this example on page 67, it's the sine x, the function between 0 and pi. And then the solution is, of course, we need to divide the interval and to use the point. For example, if we divide the interval in two, then it gives two segments. And two segments, if we calculate the length of each one and we add the results, we get an approximate length of the arc. If more intervals are chosen and more, of course, segments are calculated, we'll go closest to the real value of the length of the arc of this curve. Of course, there is a table. If these are 8 segments or 16 or 32 or 64, and it goes closest to 3.82. For the second example, the square root of x plus 1 between 0 and 3, the same method. If we begin by dividing, for example, in n line segments, then it gives these lengths, and if we add them, we can of course use a program like Excel or calculator, and it gives these values. Adding them, it gives the real. This one, for example, if it's the same but 8 line segments, of course, smaller segments, and of course more calculation is done, the length of each segment, and all the lengths are added together to give the arc length, which is closest to 3.168. Okay, here another example, the question 11 is 68, the x squared plus 1, the part of the parabola between -2 and 2, and the part, and divided in 4 segments, these, all these numbers, okay. Of course, when you get this video, you can pause wherever you want and check the values. Here is the result. If it's 8 line segments, then these are, here we are, all the values. We just need more time to do it. There is no real difficulty. It's the same thing we are repeating again and again, and it needs more time. That's it. The actual arc length is 9.2936. This actual length is given by a formula using the integral. We'll of course going through that